All right, our next review topic is exponentials, which we were good at exponentials when we first learned it. So this should be an easy, quick review. So we know exponential functions have an x in the exponent. That's how we know it's exponential. And we know the y-intercept goes on the outside of the parentheses. The rate goes on the inside. We know that the y-intercept is the starting, the beginning, the initial value. So whatever the starting number is, that's what we put for y-intercept on the outside. Bank words, they could also put like deposit. That would be the starting number, okay? For the rate, we know that the rate is how the numbers change, like over time. So like, over, like how is it increasing or decreasing over the years, okay? So if it's a percent, so sometimes they'll say, it grew by 10%, okay? You have to change it to a decimal. How do you change it to a decimal? You move 2 spaces to the left, okay? But you don't just move to the left. You also have to do 1 plus or 1 minus, depending on whether it's increasing or decreasing. So if it says increase, you have to do 1 plus the decimal. Decreasing is 1 minus the decimal. So let's do some examples. So it says, number 1, Malcolm deposits $10,000 into an account that increases by 5.2% each year. Which function models the situation? So we know that it's going to be exponential. We know y-intercept on the outside, rate on the inside. So what was my starting number? Well, Malcolm started with $10,000. That's my y-intercept. So I should have 10,000 on the outside. If I look at the outside, I'm crossing off C and D because they don't have 10,000 on the outside. Okay. The next thing we got to do is our rate. Now, our rate is a percent. Okay, so I'm going to write 5.2%. I need to change that to a decimal. Now, there is a decimal in it, but it still has a percent. So I got to move the decimal from where it is, 2 spaces, 1, 2 to the left. What do I put in the blank spot? I put a 0. Okay. But that's not all, because it said increased. Does increase mean 1 plus or 1 minus? It means 1 plus. That's what we just talked about. So I'm going to do 1 plus 0.052. You would type that in decimals. You get 1.052. That goes on the inside of the parentheses. So looking at my answer choices, that's going to be A. B is if you did not move the decimal enough. Okay, you had to move it 2 spaces. And we get this one. Okay. Number 2, after each round in the NCAA tournament, half the teams are eliminated. If the initial number of teams in the tournament is 64 teams, which function represents the number of teams left after X rounds? So again, we're doing y equals the y-intercept on the outside, rate on the inside. So what was our starting number of teams? The initial number of teams is 64. So 64 goes on the outside. Now that does not help because all the answers have 64 on the outside. So we got to figure out the rate. So again, the rate is how they change each year or slash after each round. What happens? Well, half the teams are eliminated. So first of all, that is not a percent. So I just need to figure out what number is half. I know half is 1 over 2. That's literally what half means. Okay. But all my answer choices have it as a decimal. So if you don't know what 1/2 as a decimal is, you would type it in. So we would type 1/2, and it says 0.5. Okay. And again, we said this is not a percent, so I don't need to change it. This is it. This is the rate. I'm not, move it 2 to the left and 1 plus or minus. Just this. Because it didn't say 0.5%, it just said half. So that is my rate. So 0.5 on the inside. So I need to read carefully and find 0.5 on the inside. That's going to be C. We're reading carefully. This is 0.05. That's not it. These both have 1s in it. We know that's not it. Okay, 0.5. So you got to read, make sure you're reading. Did it say percent? Like in this one said percent, or does it just say a number? Okay, the last one we're going to do together is about graphs because we're still not very good at graphs. But we can do this. This is not difficult. So it says which graph represents, and it gives us an equation. So this is the same thing we've been doing. Oh, what am I going to do with this? I'm going to type it in Desmos. Okay. So I'm going to type, delete that, F parentheses X. I'm typing exactly what it says in the question. Okay. So I see this. I'm looking at my graphs. Now my graph does not go by the same numbers. So we need to read it carefully. What should I be checking? I should be checking the y-intercept. So let's look at my graph. In my graph, I'm clicking the dot for y-intercept. The y-intercept's at 2. I'm going to check these y-intercepts. I know that is where it is. Okay. So this is between 0 and 5. So that, possible. Great. Between 0 and 5. Possible. This is at 5. That is not, no, can't be that one because it's supposed to be at 2. This one's at 10. So that's definitely not right either. So since both of those are possible, next we have to check the number at 1. So I go over to 1. I go up to the line. What number is it on? This is on a 10. On this one, I go over to 1, up to the line. This is on 5. So I need to go on my graph to the number 1. Now, if I don't see a 1 down there, I can zoom in until I see a 1. Zoom in until I see a 1. I'm moving my graph. There's the 1. Okay, so I need to go up. Here's my 1. I need to go up and see what number the graph is on at 1. So if you notice down at the bottom, I still see the number 1. So that's helpful. I'm still looking at that line to see where it touches. Okay. So right there, I'm clicking and dragging, and it tells me all the numbers on this line. So if I click and drag until I get to 1, it said the number at 1 was 10. So I look back at my graph, which one said 10? Oh, that's going to be this guy right there, which was A. Okay, that is how you check. Not just, oh, it swoops up. I don't know which one it is. Double check. Make sure the numbers are right. So you're going to go ahead. Oh, no. There's one more. One more we're doing together. Because this one's complicated. There's a lot of reading, and we're not great at reading. So it says a bank account earning annual compound interest was opened and no additional deposits or withdrawals were made after the initial deposit. Do I really care about that? No. Okay. The balance in the account after X years can be modeled by, and they give us an equation. Equations are important. I'm going to circle the equation. That's important. So we're going to have to do something with that. It says, which statement is the best interpretation of one of the values of this function? So that means they want to know, do you know the difference between these two numbers? Well, I know in this equation, the 1200, since the 1200 is on the outside, I know 1200 is the y-intercept, which we said is the starting number. Okay, we know the inside number, 1.036, that's the rate. So that's how it changed. Now, since it's a decimal, that's making me think it was a percent. Now, when it was a percent, if I got 1.036, does that mean that it was increasing or decreasing? Well, if it's bigger than 1, that means it was increasing. Okay. Why is this not writing? Okay, so let's look. A says the initial balance, aka the starting number, because we know that means starting, decreases at a rate of 96.4% each year. That's a decrease. We know, first of all, it was increasing, so it's not A. B, the initial balance of the account was $1,036. No. The starting we said was 1,200, so that's a no. The balance in the account increases at a rate of 3.6% each year. Increases. It does increase. Yes. Okay. Well, that's a maybe. We'll keep that. The balance in the account at the end of 1 year is 12. No, we said 1,200 was the start, not at the end of a year. Cross that out. So that means C has to be the answer. Okay? You just got to read it carefully. You need to know, like, pick out which number was the y-intercept, which was the rate. Depending on what the rate is, does that mean it was increasing or decreasing? Okay? So you're going to go ahead and get started on the practice.